The easiest way to tackle such question is by using the grid method. Now what I mean by the grid method is that I usually start with a 4x4 grid. The 4x4 grid basically maps the location of all the holes, so any possible holes I can mark on the 4x4 grid, and I will be able to predict what kind of holes will be present by the end of unfolding the paper. As you can see here, there's two holes that are being punched in, so they are here and here. Therefore, I know that these two holes are basically mapped on the grid at these two locations. Basically, using the grid method, I have predicted there will be two holes at these two locations, here and here. Now, the next unfold is, so this is image number 1, this is image number 2, and that's image number 3. And to go from 1 to 2, we know that you just put these two holes, and that's what I have here. Now to go back from 2 to 3, I know that there is one unfold that I have to do. And this unfold is at this axis of symmetry. And so the goal of this strategy is to find the axis of symmetry. And any holes on the axis of symmetry are usually mirrored on the opposite side. So let's see what I mean by that. As you can see by the red dotted line, the axis of symmetry is this axis of symmetry, which means any objects present on this side will be present on this side. So, if I have two holes here, I have to map the axis of symmetry on this grid, which means that the axis of symmetry is present here. Therefore, any holes against the axis of symmetry, such as this hole, will be mirrored to this side, so it should be here. And that is what I have. So far I have 3 holes, with this hole being mirrored against this hole. Now any hole on the axis of symmetry will not be mirrored, because technically this is a half fold, just like it's shown here. So this half hole is mirrored on the opposite side, and all I get is the rest of the hole. Whereas this hole will be mirrored on this opposite side as I unfold the paper, and so I would have one hole here as well. And what I end up with so far is 3 holes. So the next fold that I have now is from me going from this image, which is image number 3, to just the plain regular square piece of paper. And I can do this by folding this piece to the opposite side. So this is the axis of symmetry. If I can find the axis of symmetry, it becomes so simple, because all I have to do is that I have to mirror any holes mapped on the grid against that axis of symmetry. By mapping the axis of symmetry on the grid, I am able to find which holes will be mirrored against that axis of symmetry. And what I have here is these 2 holes. These 2 holes should be mirrored against the axis of symmetry. Now this hole is not mirrored because my square piece of paper just goes from here, goes down, and goes this way. So all I'm doing is I'm flipping this against this axis of symmetry. So I should end up with 2 more holes. And that is what I have here. By folding this piece of paper against this axis of symmetry, I end up with 2 more holes. And so a total of 5 holes. In this case, the correct answer is B. I end up with 5 holes that look like this, and that's exactly what I have mapped on the grid that I have drawn. So let's recap. On the test, I'd immediately draw my 4x4 grid. What I then have to do is that I have to map the first set of holes. So they would be here and here. I then have to find the next axis of symmetry. So I am folding this against this line. And so this means that my axis of symmetry is here. And so this hole is mirrored against that line, which is here. Then I have to find the next axis of symmetry, which is this line, and so it's this line here, which means any holes against that line would be mirrored on the opposite side. And because this is just one whole length, I'm going to mirror only these two holes against that, and what I end up with is B. Let's go through this question. Again, using the 4x4 grid, we are able to answer this question very easily. So first, let's map where these holes would be. So these holes would be here and here. Now I have my set of holes. I need to find the axis of symmetry. Now in this case, I am folding this piece of paper against that axis of symmetry, which is this. So any holes in this piece of paper are being folded on the opposite side. And if I have to map this axis of symmetry on the grid, it would look something like this. That means any holes within this quadrant, or this piece of paper, will be folded on the opposite side. And so that's what I have here. Two new holes, because they are being mirrored against this line. So now I have a total of 4 holes. The next fold is going to be against this line. So that's all I have left. So by me going from image 2 to image 3, all I did is that I folded this piece of paper against this axis of symmetry, and I ended up with this final fold. Now this fold is just this piece of paper being folded up against this line of symmetry. So if I want to map this line of symmetry on the grid, it would be here. Now, the only holes that can be mirrored against this line of symmetry is within this quadrant. Right? So this means this is the only hole that will be mirrored against that line. And so now I have a total of 5 holes again. Now this awfully looks like answer number D. And therefore, the correct answer is D. Let's recap what I have done here. Draw my 4x4 grid quickly, which I'll be using to map where the holes will be. Draw my 2 holes, my original 2 holes. Find the line of symmetry, and in this case, it's here. Just going to draw it. Mirror the holes against the line of symmetry. Find my new line of symmetry. In this case, it's here. And so I'm going to map it here, and I'm going to put it here. Now, of course, I have to be careful. This is not a hole. This is just the 2 lines of symmetries meeting, so I'm going to erase that. And so what I end up with is an answer that looks awfully like D, and so the correct answer is D. Let's go through another question and see how the grid method works again. Now the questions are getting kind of complicated, but no need to worry. The grid method is very easy to use, and it will help us a lot. So we should start off with our 4x4 grid. Map the first hole, and in this case, there is the hole, and it's 1 hole down from this side and 1 hole down from this side, so this means it's going to be in this square. After this, I need to find my axis of symmetry against which this object is folded up to go to this object, and from what I can see, I think the axis of symmetry would be here. And that is what I have. The axis of symmetry is indicated by the red dotted line. So this means that I have to map this axis of symmetry on the grid, which means it's going to be here. So any holes against the axis of symmetry would be mirrored to the opposite side. So now I have a set of 2 holes. And if I'm actually going to map them on the object, they would be here and here. Now remember, this is a half hole because I still have to unfold it. So let's see what I mean by that. Now the next axis of symmetry is me folding this piece against that axis of symmetry, which means any holes within that quadrant will be mirrored to the opposite side. So this hole is there, and then there's that half hole on the line of symmetry. And like I said before, any holes existing on the line of symmetry will not be mirrored to the opposite side because they do exist on the line of symmetry, and there's only a half hole here, so the other half would be after I unfold it. So when I unfold this piece of paper, I should end up with 3 holes in total. So that's the line of symmetry. I'm going to erase this old line of symmetry. So the new line of symmetry is there. I have a total of 3 holes, where this hole is mirrored against that line of symmetry, resulting in this new hole, indicated in brown. Now that I have a total of 3 holes, I have to find the final line of symmetry, and I have indicated that on the original image by the red dotted line. And so if I unfold this piece of paper against that line of symmetry, I end up going back to the original piece of paper, which is just a plain square. Now I need to map this line of symmetry on the grid, and so it's going to be here. It's in the middle of the piece of paper. So if I mirror the 3 holes that I have against that line of symmetry, I should end up with 6 holes. And that's exactly what I have here. 6 holes in total mirrored against that line of symmetry. Which means that the correct answer is E. Now let's recap. I always like to recap and show you exactly how I go step by step, so that you can understand how easy and how quick it is on the test to do this. So you draw your 4x4 grid. You map the first hole. Mirror the first hole against the line of symmetry, which is this line of symmetry, which is here. So I map that hole. And then the new line of symmetry is here, because I'm unfolding this piece of paper against that line of symmetry. So it's here. And so this is the new hole. And then I end up with this structure. And if I unfold this structure going this way, and going this way, so this line of symmetry is here. And so I have 1, 2, 3. All I'm doing is that I'm mirroring these against the line of symmetry, and I'm resulting with these 3. So all I have is E. That's the correct answer.